In an earlier video, we looked at this function, f of xy equals x cosine y, and we determined that it had infinitely many critical points. For all of those critical points, the x value was 0, and the y value was just some odd multiple of pi over 2. What I want to do now that we have our second derivative test, is I want to try to classify those points. Now, there are infinitely many of them, but because there was a pattern, I was able to write down one sort of generic formula for them. I should probably have stated n is an integer here. So I'm hoping that we'll be able to classify all of these without having to look at them one at a time. Okay, so let's just take a look. F sub x is just cosine of y, and f sub y is negative x sine y. We had determined that, of course, in finding the gradient to figure out that these were the points that made that gradient equal 0. I need to know them now because I need to know my second partials. So f sub xx, that's just going to be 0 because there are no x's in that formula. F sub xy will equal negative sine y. If I look here, f sub yx is going to be negative sine y. Notice that's the same as f sub xy. These second partials are continuous, and so the two mixed partials are the same. Kind of nice to just double check that you're getting that, because if you're not, something's gone wrong. If you correctly calculate the mixed partials and they're different, the test doesn't apply, because if they're different, then they're not both continuous, and then you can't use the second partials test. Okay, f sub yx is going to equal negative, I'm sorry, not f sub yx, we just did that. F sub yy is going to equal negative x cosine of y. Okay, so my formula for D is that it's going to be the determinant of f sub xx, f sub xy, f sub yx, f sub yy, which is going to be the determinant of 0, negative sine y, negative x cosine y. Now what I'm doing is I'm just writing out the functions here. I know that I'm going to need to evaluate at this critical point. Because there are infinitely many of them, I'm trying to simplify the formula as far as I can before I start plugging in. So this determinant would just be 0 minus sine squared y. That's actually quite nice, because since this is negative sine squared, if sine of y is 0, I'm going to get 0. Otherwise, I'm getting something negative. And I know what I'm plugging in for y was an odd multiple of pi over 2. Now, for an odd multiple of pi over 2, that would put me on the unit circle here or here. If it's an angle whose terminal ray passes through this point, sine is 1, so sine squared is 1. If it's an angle that passes through this point, sine is negative 1, sine squared is still 1. Okay. So I can say that D at any critical point is always going to be less than 0. And remember, a way to make that happen, obviously not what happened here, because here this is 0. So these non-mixed partials did not have opposite signs. But a way to make D negative is if the mixed partials have opposite signs, which gives me different concavities for those cross-sectional curves. I think of this way of making D negative to help me remember what that means for classification. So I can say all critical points are locations of saddles. And I am very careful about saying it's the location of a saddle. With maxes and mins, that becomes more important because the max is the value of the output. The max is not the location at which that output occurs. Okay, so with saddles, we don't really say the value. I guess we could say the value at the saddle is the z value at the saddle. But I'm always just going to be very clear that the point P naught is the location of the max, the min, or the saddle. Okay, So kind of nice. I will just point out, in this case we were squaring things. If I had gotten that my second derivative was the opposite of sine of y, then I would have infinitely many critical points, half of which would put me here, and the other half of which would put me here. I'd still be able to classify, but I'd have to think in terms of, let's see, if my integer n is even values would give me an angle coterminal with pi over 2. Odd values of n would give me something coterminal with 3 pi over 2. So sometimes when you have infinitely many points that you're describing using some variable that usually takes on integer values, you may need to classify into subgroups this set where n is an even integer and this set where n is an odd integer.